10-97, letter A and B, it says Antonio and Luann are trying to explain their strategy for computing the sum of a geometric series. They decide to generate a sequence that will be easy to sum so they can convince their classmates that their strategy really works. They decide to use T of n equals 3 times 10 to the n minus 1. The sum of the first 6 terms of the series is easy to calculate. You can do it in your head. Write out the first 6 terms and calculate the sum. So if you want to write out the first 6 terms, what you need is the formula, which they gave it to you in the problem, and then you're going to write, I just write 6 empty places where I'm going to put each of the 6 terms with plus signs in between them. So I get the first term by plugging a 1 into the formula. So 3 times 10, and then 1 minus 1 is 0. So 3 times 10 to the 0, because 1, if I plug that 1 in there, 1 minus 1 is 0. 10 to the 0 is 1, so that's 3 times 1, that's 3. Now if I plug a 2 in right here, then I go, start right here, 10 to the 2 minus 1. 2 minus 1 is 1. 10 to the 1 is 10. 3 times 10. And you write the answer right here. Now you plug a 3 in. 3 minus 1 is 2. 10 to the 2 is 100, and 100 times 3, that gives me 300. Plug a 4 in. 4 minus 1 is 3. 10 to the third is 1,000. Times it by 3. Get the idea. You're using these terms, and then when you add them together, it's just 300,000, or it's 333,333. So it's just a bunch of 3. You can add them up. I mean, you can line them up if you want, but you can just do it by place value. And then, so letter B says, now explain Luann and Antonio's strategy for calculating the sum and use your answer to part A to check your result. So we worked on this in class last week, and the book was trying to get you guys to, like, maybe you could write the series, and then maybe you could, like, add it to itself or subtract it from itself or do something to somehow be able to sum these up. Because if I try to do it like an arithmetic series, like if I add those 2 together and add those 2 together and add those 2 together, they don't all add up to the same number, so it doesn't work. So the way that you do this is you rewrite the series, but you multiply it by 10. Because see how it's getting multiplied by 10 every time? Times 10, times 10, times 10. So I'm going to multiply the series by 10. And I'm going to write it right underneath the original series. But when I write it underneath there, the last term, when I multiply 300,000 by 10, it makes it be 3 million. I ran out of room. I would write it right out to the side, but I had to write it down here because I ran out of room. So you add 10 times, you subtract 10 times the series from the original series, but you have to shift it over so that stuff will cancel out. So if I'm subtracting one of these from the other one, the 3 will come down, and I'll have the series minus 10 times the series equals 3, and then all this stuff, 30 minus 30 is 0, 300 minus 300 is 0, because I'm subtracting. All these will cancel out, except for the last one down here is 3 million. So I brought it down over here. And so I end up with the series minus 10 times the series equals the first term minus the last term of 10 times the series. 10 times the series, not the last term of the series. So then I'm going to factor out the s of 6. See, like if I multiplied this back, see how I'd have 1 times the series minus 10 times the series? I just factored it out. And then I can work inside here. This is 1 minus 10. That's negative 9. And then I can divide both sides by negative 9. And I put that in my calculator and I get the answer. So, and then if you want to see letter C, there's a different video for that one.